Welcome to KODY channel. Today we are going to discuss magnetism and electromagnetism. First of all, I am thankful to everyone who supported my channel and subscribed my channel. My main motto of this channel is helping to the people who are preparing while doing their works. My channels may helpful them who are preparing for these competitive exams. Before going to the topic, please subscribe my channel and hit the like button, like and share my video to your friends. Let's start the topic. The uniform magnetic field. Here we can see that uniform magnetic field. The question asked as uniform magnetic field. Here the options given as the field of a set of a parallel conductors. Uniform magnetic field is the field of a set of parallel conductors? No. The field of a single conductor? No. The field in which all lines of magnetic flux are parallel and equidistant. This is the right option. Here we can see that which all lines of the magnetic flux are parallel and equidistant. Here we can see that parallel and equidistant. The uniform magnetic field is if the magnetic flux are in parallel lines and equidistant. The straight line of magnetic flux is defined as, here we can see that the straight line of magnetic flux is defined as, here the options are given. Here you can see that a line vertical to the flux lines, the mean length of a ring-shaped coil, a line of magnetic flux is non-uniform field, a line of magnetic flux which does not follow the designed path. Here they asked as the straight line of magnetic flux is defined as, the option is a line of magnetic flux which does not follow the designed path is called as the straight line of magnetic flux. The magnetic reluctance of a material. Here they asked as the magnetic reluctance of a material. Here they given the options: decreases with increasing the cross-section area of the material, increases with increasing the cross-section area of material, does not vary with increasing the cross-sectional area of the material, any one of the above. Here we can see that the magnetic reluctance of a material is decrease with increasing the cross-sectional area of the material. The magnetic reluctance of a material is decrease with increasing the cross-sectional area of a material. Option A is correct answer. Here they ask the question is the ratio of intensity magnetization to magnetization force. Here we can see that intensity of magnetization to magnetization of force is known as flux density, susceptibility, relative permeability, none of the above. The ratio of intensity magnetization to magnetization force is known as susceptibility. Option B is correct answer. The unit of flux is same as, here they asked as the unit of flux is same as that of reluctance, resistance, permeance, pole of strength. The unit of flux is same as pole strength. Unit of flux is same that of the pole strength. The pole strength unit and the unit of flux as same. Magnetism of a material can be destroyed. Here they ask to destroyed material. Heating, hammering, by inductive action of another magnet, all of the above. Here they asked that destroying of magnetism. how we can destroy these magnetism for a material. Here the option is all the above. By heating you can destroy the magnetism. By hammering you can destroy the magnetism. By inductive action of another magnet we can destroy these magnetism. The option D is the correct one. Which of the following is a unit of magnetic flux density? Here they asked here unit of magnetic flux density. You can while you can reading the question, you can take the important lines like this. You can easily answer the question by seeing like this unit of magnetic flux density. You can see these options: Weber, lumens, Tesla, none of the above. The unit of magnetic flux density is a Tesla. It is easily remember that this Tesla is a electrical car. But here in our topic, you can remember that the magnetic flux density is a unit of Tesla. Which of the following is a ferromagnetic material? They asked as a ferromagnetic material. It is a keyword that you can get the answer in these options. Here they asked which of the following, and it's in what are the options they given. You can find that what is a ferromagnetic material: tungsten, aluminum, copper, and nickel. From these following options, the ferromagnetic material is nickel. Which of the following is expected to have maximum permeability? Here you can see the keyboard has a maximum permeability from a given option. Which one is a maximum permeability? Expected that maximum permeability: brass, copper, zinc, and ebonite. The option is ebonite is a maximum permeability. Reciprocal of permeability. Here you can see that reciprocal of permeability. By inversing of this permeability, what is the answer is the options are reluctivity, susceptibility, permeability, and conductance. Here we can neglect these permeability. Actually, the reciprocal of permeability is a reluctivity. The option is A. The magnetic reluctance of a material. Here you can see that the magnetic reluctance of a material. The magnetic reluctance of a material. You can see the option decrease with increasing the cross sectional area, increase with increasing the cross sectional area of material, does not vary with increasing the cross sectional area of material, any one of the above. Here you can see that the magnetic reluctance of material does not vary with increasing the cross sectional area. So option C is the correct answer, that the magnetic reluctance of material does not vary with increasing the cross sectional area of the material. Here you can see that the magnetic moment is a pole strength, universal constant, scalar quantity, and vector quantity. The magnetic moment is a vector quantity. The core of, here you can see that the core of electromagnet should have low correlativity, high susceptibility, both of the above, none of the above. The core of electromagnetic should have both low and high susceptibility and low coercivity. Option C is correct. Which part of the magnetic, here you can see that which part of the magnetic path requires large m.m.f. Which part of the magnetic path requires large m.m.f? Air gap, coil, inductance, and core. Here you can see that which part have large m.m.f. The air gap has a large m.m.f of the magnetic path. The strength of an magnetic, the strength of electromagnet can be increased by. Here you can see that the electromagnet, the strength of electromagnet can be increased by increasing the cross sectional area, increasing the number of turns, increasing the current supply, all of the above. We can see that the strength of magnetic field can be increased by all of the above. By doing all these, you can increase the electromagnetic strength, that is increasing the cross-sectional area, increasing the number of turns, and increasing the current supply. By doing these three, you can increase the strength of this electromagnet. The attraction capacity of electromagnet will increase if this attraction capacity of electromagnet will increase. The attraction capacity of electromagnet will increase if the core length increase, core area increase, flux density decrease, flux density increase. The attraction capacity of electromagnet will be increased by flux density decreases. By doing these, flux density decreases, the electromagnetic attraction capacity is increases. Temporary magnets are used in, here you can see that temporary magnets are used in loudspeaker, generators, motors, all the above. You can see that all the above. We can use temporary magnets in loudspeaker, generators, and motors. Which of the following materials are diamagnetic? Here you can the given that which are following materials are diamagnetic. Given in given options, which one is a diamagnet? Silver and copper and iron. The diamagnetic materials are silver and copper. Unit for quantity of electricity. Here you can see unit for quantity of electricity is ampere over watt joule coulomb. The unit of quantity of electricity is coulomb. Magnetism of magnet can be destroyed. Here you can see that the magnetism of magnet can be destroyed by heating, hammering, by inductive action another magnet, and this is all the above. It is a repeated question in some of the competitive exams in the central and state wise. Please remember that these magnetism of the magnet can be destroyed by heating, hammering, and by inductive action of another magnet. The bar magnet has, here you can see that the bar magnet has dipole moment, monodipole moment, both A and B, none of the above. The bar magnet has the dipole moment. A key part is used to, here you can see that a key part is used to change the direction of magnetic lines, amplifying flux, restore the lost flux, and providing a closed path for the flux. The key part is used to provide a closed path for flux. Paramagnetic material have relative permeability. The paramagnetic materials have relative permeability slightly less than unity, equal to unity, slightly more than unity, equal to ferromagnetic materials. The paramagnetic materials have slightly less than unity than relative permeability. The commonly used material for shielding or screening of magnetism is, here you can see that commonly used material for shielding or screening magnetism is copper, aluminum, soft iron, and brass. The commonly used material for shielding and magnetism is soft iron. Please subscribe my channel.